Hi everyone, welcome back to another video lecture from Miss Semino. This afternoon we're going to be talking about solutions, and in section 1, types of mixtures, we're going to distinguish between electrolytes and non-electrolytes. We're going to talk about solute-solvent combinations. We're going to talk about the differences between suspensions, colloids, and solutions. And many of you maybe have taken some water and some sugar, and you have poured the sugar into the water and it's dissolved, and that means that the solid is no longer visible. We would describe sugar as being soluble, and that means it's capable of being dissolved. So when you take that water and you take that sugar, you combine it together, we're going to call this a solution. And so a solution is a homogeneous mixture of two or more substances in a single phase, and so the one we're talking about would be obviously in the liquid phase. So on this slide, we need to distinguish between the terms solvent and solute. So if you've ever made Kool-Aid before, as shown in this drawing here, when you add the water is called your solvent. Then when you add the substance to be dissolved, that's going to be your solute. So when you add your Kool-Aid in here, the Kool-Aid is your solute. So it talks in here about solutions may exist as gases, liquids, or solids. There are many possible solute-solvent combinations between gases, liquids, and solids. So it doesn't always have to be between a solid and a liquid. So some examples that we have here are alloys are solid solutions in which the atoms of two or more metals are uniformly mixed. Brass is made from zinc and copper, and sterling silver is made from silver and copper. So remember, one of the objectives here was to talk about the difference between solutions, suspensions, and colloids. So we just talked about solutions a second ago. We said that there were homogeneous mixtures that looked the same throughout. In a suspension can also initially look the same, but what's going to happen is that the substances will then will come out of solution. So the classic example of a suspension is this idea of muddy water. So you have a glass of water, you add some dirt to it. You can initially have, like all the dirt particles floating, and it can look uniform at first, but after a while the mud will go ahead and settle out at the bottom of your jar. So the formal definition here, it says if the particles in a solvent are so large that they settle out unless the mixture is constantly stirred or agitated, the mixture is called a suspension. And then so here's our example. For example, a jar of muddy water consists of soil particles suspended in water. The soil particles will eventually all collect at the bottom of the jar because the soil particles are denser than the solvent, the water. So one way that we like to classify if it's a suspension or not is if the particles are larger than 1,000 nanometers in diameter. And you're going to see that we're going to use the size of your particles, of your solute particles, to classify colloids and suspensions as well. So colloids are the third type of mixture that we need to discuss. So colloids are classified as particles that are intermediate size between those in a solution and a suspension. And so remember, the suspensions have those really large particles that come out of solution. They fall to the bottom of the glass. While in solutions, particles are held up in the liquid or the solute for the whole time. Okay, so it talks about here the solute particles in a colloid are small enough to be suspended throughout the solvent by the constant movement of the surrounding molecules. So this one you also don't have to keep constantly stirring. Colloid particles make up the dispersed phase, and water is the dispersion medium. So some examples of colloids that you probably use all the time are mayonnaise, and it's an emulsion of oil droplets in water. So remember that colloids have particle sizes that are in between suspensions and solutions. So we might say that many colloids look similar to solutions because their particles cannot be seen. However, unlike solutions, colloids experience this thing called the Tyndall effect. And the Tyndall effect occurs when light is scattered by the colloid particles dispersed in the transparent medium. So a good example of this is if you've ever seen like headlight on a foggy night. So the Tyndall effect can be used to distinguish between a solution and a colloid. Here is a good picture to tell the difference between a solution and a colloid. So remember, in a solution the particles are super small and you can't see them. But if you look at a colloid, you really can't see the particles either. But believe it or not, the particles are a little bit larger. And since the particles are a little bit larger, like this flashlight that's over here shining this light, the light actually gets kind of diffracted, that was the word I was looking for, off of these like little particles. So it kind of like spreads out the light. Where over here, when the light hits it, the particles are so small that it's really not like spreading out the light. Here is a nice little chart that talks about the difference between solutions, colloids, and suspensions. So again, solutions are homogeneous. That means they look the same throughout. They have really small particles, so like the size of atoms, ions, or molecules. They don't separate out. If you just let it sit on the counter, the particles don't fall to the bottom. You can't separate these by filtration, and they don't scatter light, meaning that they don't experience that Tyndall effect. Colloids, on the other hand, would be considered heterogeneous, medium particle size. They do not separate, and they can not be easily filtered because the particle size is still pretty small, but they do experience this Tyndall effect, or this like diffraction of light. Remember, suspensions had the largest particle size, so this is definitely something we would call heterogeneous. Those particles settle out or fall to the bottom of the glass. They can be separated with filtration, and they can scatter light, but it doesn't often, it's not as cool of an effect as if it's a colloid. So finally in this video, I want to go ahead and discuss the difference between electrolytes versus non-electrolytes. So a substance that's dissolved in water in a given solution that conducts an electric current is called an electrolyte. So it likes electricity. So the reason that we would consider something an electrolyte is if it was an ionic compound. So the classic example is sodium chloride. So remember, an ionic compound has a metal, and then it also has a non-metal. And more importantly, the one is first made up of a cation, or a positively charged, and the second half is made up of the anion, or the negatively charged particle. So the positive and negative ions separate from each other in solution and are free to move, making it possible for the electric current to pass through the solution. So remember, when you drop your sodium chloride or your salt into solution, it's popping off into those sodium ions and those chlorine ions. Solutions can be classified as non-electrolytes, weak electrolytes, or strong electrolytes. Non-electrolytes don't conduct electricity. Weak electrolytes conduct some electricity, and strong electrolytes conduct a lot of electricity. So hopefully, looking at these pictures, you could see how sucrose would be classified as a non-electrolyte because it's not conducting any electricity. Acetic acid would be considered a weak electrolyte because it is conducting some electricity. Sodium chloride would be considered a strong electrolyte because it's conducting a lot of electricity. And then hydrochloric acid, you can see it's even brighter there. And that's because those ions dissociate even to a greater rate. So if we look at the particle view at the bottom of each slide, you can see how the sucrose molecules, the sugar molecules, stay together. Remember, in order to conduct electricity, you need to separate out into those individual ions. You can see that we have some ions separating here, but again, the ions are fairly large, and we only have a few hydronium ions. If you look over here, you can see that there was a complete separation of those particles. And then in the final slide, you can see that you have these hydronium ions in here as well. And so that's what's going to make this and this considered to be strong electrolytes. So just as a quick review, remember in this video we talked about solutions, the difference between the solvent and the solute. The solvent is the thing that's doing the dissolving, the solute is being dissolved. And then we talked about the properties between solutions, colloids, and suspensions, as well as the difference between electrolytes and non-electrolytes. Please see me in class if you have any questions.